Hi dear students, this record is about the model creation issue and view creation and surface painting. I'm going to answer all of such questions on this example. It is from the content of one of the worksheets. It is, as I remember, ID number of the worksheet is 15. Okay, already studied on this example, created the model of the object where in Inventor. You know this. But here, this classwork is to demonstrate the same things in AutoCAD. You know, in the course content, not only AutoCAD, but you're learning the tools of Inventor, and near future start to learn the tools of Revit. Okay, how the model of the object can be created in AutoCAD environment. Start and then go ahead. I open AutoCAD, mechanical, and then it is going to be a new creation. Clicked on new file creation button. Well, since the issue is three-dimensional model creation issue, I don't want to use the two-dimensional template. For two-dimensional drawings, you know, I keep my template. It is complete to its structure. I have in the structure of my template necessary layers, and its configuration is all okay. But here I'm going to use AutoCAD not to draw the views of an object, but to create the model of the object. So, select a template option from this list. Okay. To say that gonna obey the rules of ISO, select ISO template and then say open. Selecting ISO template, I said that I taught to the software that I'm going to use millimeter. Whatever thereafter I input using the keyboard by writing the number, it is going to be recorded in millimeter. You know this. Okay. I already changed the mode from 2D to 3D, but say not a matter for the first sketch, it is 3D invent or 2D invent. For instance, turn back to two-dimensional mode, you know how, and then draw this boundary lines. Well, as I explained, the reason in studying on the same example in Inventor environment, I'm going to start from here, have the boundaries of the surface, omitting the channel at the first stage, and of course the base of the cylindrical feature. Okay, it is going to be the first sketch. In model creation process for this object. Okay. To be able to find the drafted things in the size of suitable size as fit into the display, you know, this is recommended. Here the paper is unlimited. No need to have a paper simulation, but say this is recommended. Right zoom, this command, select from the list that option with a click, and then drop the list of the options, clicking on, as it is implied by this little arrow, down direction key of the keyboard. Then from the list, select all. And after making zoom all, such a comment, and then saying all, what does it mean? If you have a drawing, okay, in the environment. Clicking on zoom all button, you can see, zoom extend button, you can see all the drafted things in the display as much as possible in the full size. Yes, you know this. Okay, then to be able to have the first sketch, I'm going to use modern method, or if you want, you may use classical method for two-dimensional drawing. It is going to be the first sketch. Created a circle arbitrarily, and then now from the worksheet I know the diameter of that circle. Since that diameter in my consideration is the base of this extension on the surface of this right prismatic part, well, whatever the diameter of the cylinder is, it is base, it will be in the same size. So 32 is the size of that circle. Okay, I mean this intersection, it is the base of the cylindrical extension, while the area bounded by this circle is the base of cylindrical extension, you know. Okay, so 32 is the size. Dimensional constraint, since I selected modern method. But by the way, modern sketching method is applicable in 2D environment. After changing the mode from 2D to 3D, then well, need to use the classical method. It is at least for today is necessary, is a must. I don't know in future whether modern method will be applicable in 3D environment as well. I don't know. Okay, home ribbon, and then well, parametric ribbon, diameter inputting button, indicate the circle, and then say that it is size is 32. Press enter. Since I said zoom all, for instance, just test, clicked on zoom extend button, then the circle will be in the screen in full size. Okay, zoom out. And then polyline. Yes, gonna create such a line here. In my mind, it corresponds to the line to have one of the tangent boundaries of the profile. Click, and then arbitrarily create one more line. This line in my consideration going to be the one of the boundaries. This is the other, this is one more, and this is the line to have the other tangent line. Press escape button, finish the polyline process. Okay, and then well, the constraints, parametric ribbon, verticality constraint. I know that this boundary is this direction, in this orientation is a vertical boundary. Okay, well, here observing the surface as if in which direction? That direction. Yes, and that boundary is, you see, vertically oriented in the screen. Okay, so that's why I input verticality as the characteristic for this line. The other is horizontal. Horizontality characteristic button is this button to click. Indicate this, make it perfectly horizontal. Clicked on this one more time, indicate it, make it horizontal. And then the other constraint, say the constraint for this line, for that line, tangency. Tangency inputting button, indicate the circle, indicate the line. Now these are tangent. Clicked on tangency button, indicate the circle, indicate the line, or vice versa. Okay, tangent. Do not apply trimming process till you reach to the end of such a sketching stage. You know the reason. Well, here the time is the sizing time. Dimensional constraint for the lines, of course. Well, the length of this boundary I know is 40. True. Have a look at. Yes, 40 millimeters. Continue. Well, at the opposite side, the distance, say the length of the other boundary, opposite boundary is the same. You know, there is a symmetry over there. The location dimension for this horizontal boundary with respect to the center of this circle. I mean, this distance is 30. I know from the pictorial figure. Yes, you see this distance is 30, and the depth of the object in this direction is 60. Since my consideration, the sketch is just to have the things on the top side of this base, this prismatic part, well, the dimensional constraint from here to there must be taken as 60. Okay, I think, well, the other constraint is the distance from the center of the base to this edge of the surface, to this boundary of the surface. It has been given as 70, you see. Okay. Constraint, dimensional constraint. From the center, you see, when I bring the cursor to the vicinity of the circle in AutoCAD, it is center point will be ready to snap the cursor, can indicate center. If you're going to indicate not the center but a point in the circumference in the circle, along the circle, then down direction can select object option. But here my purpose is to indicate the center, indicate this point, and then say that distance from here to there is 70. Now the sketch is okay in size but not in shape yet. Trim the extensions. Start trimming process. In AutoCAD it is tricky. Press enter and then indicate the extended parts. Here I know, well, to be able to create the model of the part, well, there must be a closed region. But if there are more than one regions in AutoCAD, unfortunately, not in Inventor but in AutoCAD, well, need to decrease the number of regions to 1. If AutoCAD finds more than one closed regions, then, well, cannot consider one of them as, closed profile, cannot create the model of the feature. So since I know such things, well, at present there are two closed parts, this and that circle. I'm going to trim this part of the circle, otherwise cannot define this area as a region. Okay, trim it. And then press escape button. Well, since I created those boundaries using polyline, these are just in continuation and as if single line. But created the circle, well, using circle creation tool, not polyline. Now this arc is not a boundary of the region yet, so there is no region definition. This is as if open end. Right, so need to apply region definition process. Okay, expand drawing panel and find region definition button. Start the process and then say that this and those are the boundaries of the same region. Indicate this, indicate the others, or use windowing method, select all, press enter. And then yes, you see I added this boundary as a continuation of the others. So, well, since this is a continuous boundary, I am sure the area bounded by those is a region. Okay, then, well, time to change the mode from 2D to 3D because I need to find extrusion facility button. Well, clicked on this switching button and select 3D modeling option. Now AutoCAD is available to use all the tools in 3D mode. And then yes, extrusion process. In my consideration, this surface is the top side surface of this part. So, well, I know that thickness is 10 millimeters. I'm going to apply extrusion process and then create the model of this part. Just I'm going to follow the same way. I selected that way to follow and created the model of the object in Inventor. Yes, had this profile first and then extrusion, and then apply extrusion process creating to create the cylindrical extensions. Okay, and then created this part, then created the channel, created those, created the this truly extending channel and this blind channel. I'm going to follow the same way to it is all the stages, but going to use the tools of AutoCAD. Life will be relatively difficult for me. Okay, because AutoCAD is not a new generation software. Apply extrusion process, indicate this profile as the region, press enter, and then not in the up, but I'm going to create the prism in the down direction. Thickness is 10. Okay. Have a look at selecting conceptual option. Yes, the model of this part is okay. And then start circle creation process. Okay. Diameter. And then bring the cursor to the vicinity of the edge of this cylindrical part. And then thanks to snap enabling, the center point of that arc will be highlighted, and bringing the cursor to its vicinity can indicate it as the center. Or what? Since I deleted the valuable part of the circle to be able to have one region only, say here I need to create that circle again. Okay? Well, into the box, write the diameter of the circle, or you can indicate the midpoint of this arc to say that it is the point passing the circle pass through. Which one you like. Okay, indicate this with a click. Well, say since I selected diameter option, AutoCAD just created the circle in half size. So say oops, and then do it again. If you're going to indicate a point along this arc, then you should select circle creation option, to use radius, because from the center to the midpoint distance is radius. But if you're going to input the diameter, okay, select center diameter option. Center radius, center diameter, which one you like. Okay, center radius, start the process because there is a circle arc and can indicate it as midpoint. Instead of calling the memory on the size, just indicate center, indicate a midpoint of the arc. Then you see radius is calculated, means it is 16. 32 divided by 2. Okay, after creating this circle, apply extrusion process, indicate this region, press enter, and then, in the up direction, I know this portion, length of this portion, height of this portion is 40. Yes, created this cylinder. By the way, I forgot to save the file. Pass through the saving stage, save as, for the first time. The address, yes, correct. Generate the file name, surname, ID number, section, no, there is no section. Say that this example is from worksheet 15, object 101. And what I am doing, I am using 3D part of AutoCAD. Started to create the model of the object in AutoCAD. So I'm going to write this phrase to remind me that in the content of this file there is a solid model. I'm going to write this word solid and date of creation is April 28. Okay. And then bottom side surface, start circle creation process. Okay, and then bring the cursor to the vicinity of the circle arc. It is at the bottom side. Then it is center point going to be distinguishable. Bring the cursor to this point and then indicate it. I said that the center of the circle is over there. And then bring the cursor to the midpoint of this edge. Have such a circle. I am sure its diameter is 32. And then apply extrusion process. Indicate this circle as the region. Press enter, and then in this direction create the cylinder. Its length I know is 10. Okay. Save the file. Continue. Well, here after having the cylinder and this part, by the way, you know, in AutoCAD, created features are considered as if components. This prismatic part and the cylindrical features are not unified yet. Either at that stage say that these are not different objects but the features of the same object. Apply Boolean algebra. Using Boolean algebra, unify them. Right now or later. Which one? Whenever you desire. But at the end, it is a latest at the end, it is a must to unify the objects. To say that not object, but those are the features of a single component. Here I'm going to, this stage, create the rectangular prismatic extension. Okay. Well, since I'm going to create a rectangle over the surface, well, for my convenience, I know need to bring the coordinate frame, say to its XY axis, as coincided onto that surface. On which surface you're going to draw the sketch, then, well, on that surface, to that surface, XY plane, the plane defined by XY coordinate axis, is to coincide. So I'm going to move this gizmo, this coordinate frame from its vert location to its new place. You know, I like to use this tool for moving the coordinate plane. Okay. I'm going to indicate this corner as the origin via snapping, and then say that this is the point along the x-axis, positive side of the x-axis. Indicate this point, and then say that this corner, this ending point of this intersection, is the point through which positive part of y-axis passes. And then you see, well, this is the x-axis, this is the y-axis, and that is the origin. And then start rectangle creation process. I know the size of the rectangle. Well, the first corner is at the origin. Instead of writing 0, 0, just, if you want, snap this corner, indicate. And then, well, you see rectangle is being simulated, is in simulation. Well, AutoCAD, I know that, ready to gather the coordinates of the opposite corner. Now, for the opposite corner, abscissa value is positive. Okay, I see the corner is at the positive side of the x-axis, and its coordinate is 10. I know from the pictorial figure. Clicked on comma key. Y value relative to the precedingly indicated point, of course. Don't forget, since dynamic input is on in AutoCAD, while the written values for the following points will be measured with respect to precedingly located point. So, while relative to the first corner, the abscissa value of the second corner is 10. How about the ordinate value? Ordinate value is 60. Okay. Yes, the rectangle is in the correct size. Apply extrusion process. Be able to indicate rectangle. If you're in difficulty while trying to indicate the area bounded by that rectangle, but over the surface some other regions are being highlighted, then you know the shooting method. Change the visualization style to wireframe. You can much more easily indicate it. Extrusion process, indicate the edge of that profile, press enter, and then in this direction apply the extrusion process. The extrusion length I know is 20. Okay. Turn back to conceptual appearance. Yes, this rectangle is okay, created. And then yes, well, at this stage I decide to unify these objects, unification process, and then indicate this cylinder, indicate this part, indicate that cylinder, indicate that rectangle, say that these are the features of the same object, press enter. Then yes, it is now a single component. Okay, and then well, in the order, continue. I'm going to create the hole over there. You know, in AutoCAD, to be able to create a hole, first create a cylinder, okay, where within the solid feature, hole is within that feature, okay, and then apply subtraction process. Well, I know the diameter of the hole, saying hole I mean the largest hole, is 22, and this hole and the cylinder are coaxial. Of course, can create a cylinder well, in the vicinity of, at the outside of the existing one, and then you can move the cylinder to here and then apply subtraction. Or I know that it is edge uses the center of the edge of the cylinder, so start circle creation process in diameter mode, and then bring the cursor to the vicinity of the edge of this cylinder. Thanks to snap enabling, it is center going to be ready to indicate. Indicate the center of the cylinder and then center of the edge of the cylinder, and then write the diameter 22. Yes, after creating this circle, apply extrusion process. Indicate the circle, press enter, and then create such a cylinder within the cylinder. At this stage it is unrealistic, of course, but I know you as well. This is for creating an empty space. And then apply subtraction process. Indicate the main part, press enter. Indicate the cylindrical extension, cylinder. I created it as coaxial just to cut the material, and then press enter. Yes, you see I managed to create the empty space. Okay, and then the channel in the order. I will click on save button. I'm going to create this channel. I know if the channel were exist, while observing the object in this direction, I would see the edges of the surfaces of the channel. You know, if you're going to apply cutting, then first ask the question. Well, the selected surface is perpendicular to which side? Which surface? Well, I selected the channel, surface of the channel. Since this surface, and the other profile surface, all the surface of channel are in the same orientation, same characteristics. Three of them are perpendicular to this side. Yes, on this side surface, take a sketch right in Inventor, but in AutoCAD, bring the coordinate frame onto this surface, XY plane onto this surface, and on the surface draw the edges of the selected surfaces. To be able to have a closed region, then between this point and that point you need to have one more line. And after having the rectangle, it is gonna be the region. Apply extrusion process. In AutoCAD, yes, do similarly the things. First, bring the coordinate frame to a suitable place. Clicked on this. Of course, not suitable. I mean, to have XY plane as coincided with the surface. Okay, I'm going to define this corner as the origin and then say that this is a point. Snap this point. X-axis passes through, and this is a point. Y-axis passes through. Okay. And then yes, XY plane is coinciding with this surface. Here, although I clicked on the surface of the viewing cube and expect that I would see this profile surface to its edge, but you see model is in perspective appearance. It is misleading to see the model in perspective appearance. So see the models orthographically. Write this comment, perspective. While typing few letters, the list will drop. From the list, select perspective option. If the parameter for this comment is 1, solid model or model of the object appears in the screen perspectively. Say that you're observing it perspectively. Means observer is not at the infinity but at a finite distance away from the object. So, if the entity is little bit away, more away from the eyes of observer, then its size will be smaller. Because in perspective appearance, perspective observation, there is a diminishing point. Change the parameter to 0 to be able to observe the model, see the model orthographically. Then after making this parameter changing, observer will be at the infinity as if. Okay. And this is the surface to draw the sketch. What is that? I know the surfaces of the channel are perpendicular to each other, and including the closing boundary, can say that the necessary sketch to draw is a rectangle. I know the size of the rectangle from here. The location dimension for the profile surface of the channel is 14 relative to this edge. Okay, and relative to this intersection, the location dimension for this profile surface is 10. Okay, but here while creating the rectangle in AutoCAD, I need to create the rectangle, writing the XY values for one of the corners and the XY values for the other corner. So here relative to this corner, the coordinate of the opposite corner, I need to calculate 40 from here to their distance minus 10 minus 14. Yes, this means the width of this channel is 16. Relative to this corner, this means the coordinate of the opposite corner is 16. Since the height of the channel is 3, the other coordinate of the opposite corner is 3. Am I true? 40 minus 14 minus 10, 24, yes, 16. Width of the rectangle is 16. Okay. And then start the rectangle creation process, and now system asking me on the coordinates of the first corner. I'm going to write the coordinates, of course, relative to the origin. First point is located relative to the origin, but the second point, the following points are relocated, inputting the coordinates relative to the writing the coordinates relative to the precedingly marked point. Okay, for the first corner, x, y values. X value, I know that is 14. Check it one more time. Yes, this distance from here at this corner, I have the origin, and this is the location dimension for the vertical boundary of the necessary rectangle. Okay, so write the abscissa value 14. Ordinate value for the upper left corner is 0, comma 0. Press enter. And then yes, rectangle is in the simulation. Now AutoCAD expecting the weighting the coordinates of the opposite corner. The abscissa value opposite corner with respect to the first corner, not with respect to origin. If you want to input the coordinates with respect to the origin, then you must toggle off dynamic input button. But if I toggle off dynamic input button, I cannot find such useful compartments in the vicinity of the cursor. So I don't want to disable dynamic input facility. But I know that, well, the only thing to know is that, say, write the coordinate values relative to the preceding point. Relative to the precedingly marked point, which is the first corner, the abscissa value is 16. Clicked on comma key. Ordinate value, yes, positive. Be careful, pay attention. Y-axis is in the down direction. If it were in the up direction, then I would write the y value as negative. But here it is positive. 3 is the value. Press enter. That is it. Here is the necessary rectangle. And then apply extrusion process. Extrude. Be able to indicate this rectangle. Press enter. And then create the rectangle to be able to much more easily to indicate during the subtraction stage. I recommend with such a further extension. It is just the extended part to much more easily indicate it. And then Boolean algebra subtraction, say that subtract from this, press enter, that one. Press enter. Yes. Here it is. There is the here is the channel. Save the file. This stage, well, okay. Create the holes. Sink holes, I mean these 3 holes, these 2 holes, or these channels. Well, creating these channels are a little bit difficult, because of the difficulty in locating the coordinate axis over the surface. But I'm going to, of course, demonstrate. Although it is a little bit difficult, but yes, we can do it. Okay then, at this stage, before creating those, let me create the little bit zoom in. These channels. This channel, well, you know, about the axis of the edge of the cylinder is symmetric in this direction. It is total depth is 6, and the frontal surfaces of the channel are symmetrically located relative to the plane of symmetry. Location dimension is 6 divided by 2, 3. From the center of the edge of the cylinder to the edge of this profile surface of the channel, distance is 25 minus 11. 11 is the radius of the largest hole. It is 14. Okay. It is my plan. I'm going to have a rectangle here. It is corner, this corner, and that corner and corresponding to this edge will be at the correct place. Okay, and then, well, after creating a rectangle, this and that, those boundaries, those corners will be at the correct place over the surface. Then apply subtraction process. Okay. For this channel, similarly, you see, in that case, while relative to this axis there is a symmetry, in this direction it is blind. It is height is 7 millimeters. The height of this channel is, since it is truly extending, is 60. Okay, well, to be able to draw the necessary sketch, you know, this boundary, this boundary, this boundary. And since, you know, it is necessary to have a closed region, well, there should be other boundaries to create the rectangular prism. Now, follow me and then see how. But the main issue is the coordinate frame. Well, to be able to draw the necessary sketches for extruding the, creating the prism here and there, prisms, well, need to have the XY plane on the surface of, on the plane of this surface, the tip surface of the cylinder. Okay, then start the move process. And then, well, I can say that, yeah, origin is the center of the edge of this surface, say center of the tip surface. I can indicate it as the origin. But you see, although in snap enabling, sure, for midpoints there is an enabling, and also 3D snapping, for midpoint on edges there is an enabling. But when I bring the cursor to this part, you see, although by definition there is a midpoint, this part of the circle, but you see midpoint is not highlighted, so midpoint cannot snap the cursor, so I cannot indicate the midpoint. Well, such a point is needed to indicate, because to say that x-axis passing through, and then indicate this to say y-axis passes through. But you see, although I am moving the cursor in the vicinity of the midpoint of the circle, there is no highlighting. It is a difficulty, of course. But here in the first compartment, see the written things. System saying that specify a point, okay, at the positive portion of the x-axis. How it can be specified? If there were a characteristic point to snap, well, for instance, along this edge, remember precedingly I indicated this characteristic point. I said that, yeah, it is passing to that point. X-axis pass through. But here you see there is no characteristic point to indicate along the circle. But say writing the coordinates, I can do it. Well, that is the origin. Say that abscissa value for the point through which the abscissa axis passes through is, let's say, half of the circle, diameter of the circle is 32 divided by 16. Say that 16. Write such a number. Clicked on comma key. Ordinate value 0 for that point, because the point is along the x-axis. So ordinate is 0. Press enter. Yes, and then, well, following stage, system in that case asking the coordinates of the point along the y-axis. Okay, there should be, yes, one point is at the origin along the y-axis, the other point is needed. So where is the y-axis? Well, for the y-axis, write the abscissa value for the point being along the y-axis. Abscissa is 0, so write 0. Clicked on comma key. Ordinate value for the point, which is a point along the y-axis. Say that Okay, 30, 60, 40, write such a number. I'm going to write the half of the circle, diameter of the circle, half of the diameter of the circle. Press enter. And then, have a look at. Yes, although I expected to find the XY plane just coincided with this annular surface, but you see it is not. What can I do? Don't worry about it. If I rotate the coordinate frame about x-axis 90 degrees, then sure XY plane will coincide with that surface. If the software were invented, then wouldn't be such difficulties. But in AutoCAD, unfortunately, need to deal with coordinate system. Okay, drop this list. This is the multi-optional facility to use to rotate coordinate frame about it is one of the axes. Well, I know that if I rotate the frame about x-axis, it is on x-axis 90 degrees, so can have xy plane over the surface. So clicked on this option, it is to say rotate the frame about x-axis and then right into the box 90 degrees. 90. Press enter. You see now it is okay. XY plane is coinciding with the surface, analysis surface. Well, one more time I'm going to change the visualization mode from perspective to orthographic. Perspective, writing the parameter 0, and then the profile to have, yes, in sketch mode uses what? The edge of the surfaces of the channel, the edge of this surface, edge of this surface, edge of the other surface. While observing the object in this direction, the edge of the surfaces, if those have been already created, will be this, this, and that. Well, here at this stage, I'm going to locate this corner at the correct place, that corner correct place in creating the rectangle. This corner correct place, that corner, well, in alignment with this corner. Well, see how such a rectangle can be created. Start rectangle creation process, and for the upper right corner, write the coordinates. Abscissa value I calculated, already calculated. 25 minus 11, it is equal to 14. Abscissa is 14. Ordinate is, see the origin. Origin is over there. Ordinate is 3. Okay, abscissa value 14. Okay. Clicked on comma key. Ordinate value, say that I decided, since I said mark the upper left right corner, so ordinate value is 3. Press enter. And then yes, the corner, upper right corner of the rectangle is at the correct place. How about the opposite corner? For the opposite corner, abscissa value, well, I don't know the distance from the corner to this circular boundary. But I know that if I create the rectangle with such a further extension, can use the rectangle as the region to create the necessary rectangular prism. So as the abscissa value from the box, I see the order of magnitude. Well, since the corner relative to the first marked corner is at the negative direction, in the negative direction of the y-axis, this displacement from the preceding point to the following point uses negative displacement. So write the abscissa value as negative. Minus, for instance, say that 10 is the abscissa value for the lower left-hand side corner. Lower left-hand side corner. Okay. 10, and then clicked on comma key. Ordinate is not arbitrary. Ordinate from with respect to the upper right corner, the ordinate value for the lower left hand side corner is -6. Press enter. Yes, great. Well, that rectangle can be used for cutting material. Well, similarly, I'm going to create the other rectangle. Well, here saying other rectangle, I mean to have this channel in the end after the cutting process. Well, this corner of the rectangle upper corner is over here, lower corner is over there. But since this boundary is circular, well, I'm going to make such a thing. Abscissa values important, but ordinate not so important. Well, see what I mean. Create a rectangle. Okay. Abscissa value for the upper corner of the rectangle is 3. Clicked on comma key. Ordinate value. For instance, say that the upper corner of the rectangle is in the atmosphere. Say it is 20. Press enter. And then yes, in this direction, move the cursor. And now write the coordinates for the lower left hand side corner of the rectangle. Well, the corner abscissa value for this corner is important, but the ordinate is not so important because I'm going to have such further extensions. Rectangle will be further extended. But the width is important. So relative to the first corner, abscissa value of the second corner is 6. But since this displacement you see not in the positive but negative direction, write x value delta x as negative, -6. Okay, ordinate value for this corner relative to the upper corner, first corner, you see in the green box, order of magnitude is available. For instance, write -15, -16, okay, -20, let's say -15. It might be -10. Oh, sorry, I made a mistake. First, clicked on comma key and then into the box write minus. It is negative because you see this corner relative to the first is in the negative direction of the y-axis. Yes, in AutoCAD, while direction is important, need to have greater attention. -15, 12, something like that. The y value is not so important, but x value, yes, must be 6. Okay, and then yes, sketching stage is okay. I finished the sketching stage, and then apply extrusion process. Well, start extrusion process and indicate this rectangle, press enter, and then create the rectangle. You know, although I know that it is an empty space, well, create a solid part first. Okay, I furtherly extended this rectangle to be able to much more easily indicate it at the subtraction stage. And then apply extrusion process. In that case, indicate this rectangle as the profile, press enter, and then create this rectangular prism, not truly, not arbitrarily. It is height must be equal to 7 because 7 is the height of the empty space. Press enter. And then yes, what I have two solid rectangles. Well, these are to cut the material. Subtraction process. Okay, start, indicate the main part, press enter, and then indicate this rectangle to say subtract, indicate that rectangle to subtract. Press enter. Yes. Managed to create the channels. Save file. And then while the time to create the holes, I'm going to bring the coordinate frame onto the surface of the channel. Yes, started the process. say that this is the origin, this is the point. Well, you see, instead of writing coordinates, can indicate this characteristic point as the point which through which x-axis passes, and indicate this characteristic point to say that y-axis passes. Okay. And then here is the coordinate system. XY plane is over the surface of the channel. And then, well, from the pictorial figure, I know that the coordinates of the center of the edge of this hole, 8 millimeters from this boundary, well, due to symmetry, 60 minus 20 minus 20 divided by 2, 10 millimeters away from this boundary. Well, 8 and 10. Well, since origin is over here, this corner is the origin. Yes, you see origin is at the corner. Well, according to write the xy values for the circle to have. I start the circle creation process. It is abscissa value positive 10. Clicked on comma key. Ordinate value is positive 8. Press enter. Here is the circle, center of the circle. Diameter of the circle, I forgot the number. 6. Okay. 6. Diameter 6. Right? Press enter. Okay. And then, well, if you want, you can create the edge of the other holes. But, well, I'm going to create the first hole and then apply array copy process. Extrude. Be able to indicate this profile. Press enter and then create a cylinder. I'm going to, instead of thinking about its length, then to be able to much more easily indicate the cylinder at the subtraction stage, I am going to create it arbitrarily with such further extension. Okay, and then, well, array copy process. Rectangular array. Indicate this entity to create its copies. Press enter. And then, you know, default configuration of AutoCAD selects 4 columns, 3 rows. Well, 1, 2, 3, 4. In this direction, this means AutoCAD considering this direction as the direction along which we have the columns. Okay, 4 columns. Now, not 4, but I need to have 3 holes. So write 3. Press enter. And then, well, not 3 rows, but only 1 row. So 1. Press enter. Yes. And the distance between the cylinders, I know. I forgot the number. 20. Okay. 20, 20. So turn back to here and into this box, right? 20. Sorry, well, not this one. Yeah, it is the wrong box. Into this one, write 20. Press enter. Yes, finish the create them non-associative. Clicked on close button. And then the rest, subtraction. Okay, from the main part, indicate the main part, press enter. Indicate the cylinder, subtract them, press enter. Yes, you see, created the holes. Have a look at. Okay, almost finished the model creation stage. Clicked on save button one more time, and then, well, the other holes. For creating the other holes, this and that, I'm going to use the same technique. I'm going to create the edge of one of them and then apply extrusion and then apply array copy process. Okay, the location dimension for the center of this circle, or this one, 10 millimeters with respect to this edge. Well, 60 minus 30 divided by 2, 15 millimeters with respect to this edge, or the center of this with respect to that edge. 10 and 15. Okay. But first, we'll need to coincide XY plane onto the surface. Okay. Well, I'm going to indicate this corner as the origin. Okay. And this point as the point through which x-axis passes. This point through which y-axis passes. Okay. And then, yes, XY plane is coinciding with the surface. Okay, start the whole creation process, selecting diameter option, and then center point. Abscissa value of the center point I know is 15. It is positive. Clicked on comma. Ordinate value is positive 10. Press enter. And the diameter 12. Here is the circle. Check whether it is 12. Yeah, yes, 12. And then the rest, extrusion process, apply extrusion process, indicate this circle as the region, press enter, and then in this direction. In extruding it, well, do not arbitrarily extrude it. If it is extruded furtherly, you know, in Inventor, to be able to create the hole, apply hole process, and to say that ending surface is the opposite side of the rectangular prismatic extension. To indicate the ending surface, select two option and indicate it. If you watch the previous video record, can see what I mean. One more time. But here in AutoCAD saying that while creating this cylinder, it is for cutting the material to create the hole. Do not furtherly extend it, because if it interferes with the other solid feature, then when you subtract, then that part will also be subtracted. So, well, the length of the cylinder should be in this order. Okay, do not extend it furtherly. Okay, then create. And then apply array copy process. Indicate this feature. Well, say couldn't select first. Select a rectangular array. I started the process and then say that it is the entity. Press enter. And then yes. Well, see 1, 2, 3 columns. So into this box, right? Only one row. Press enter. Not 4, but 2 members. Press enter. And distance between them 30. So right into this box 30. Press enter. Finish array copy process and then apply subtraction. From the main part, press enter, subtract this, subtract that. Press enter. Here it is. Finish the model creation stage. Material. Okay, assign the material and then finish that, the model creation process. Well, the following part, I'm going to talk about surface painting. View creation, I'm going to skip view creation part because sufficient talk about how the view is created in AutoCAD. First angle, third angle, okay? Bring the cursor layout button, right click the mouse, select the quadrant, etc. Well, you can find the video films and then watch them again. Here, assign the material. You know how. Visualize tab. Material browser button. Start the process. Okay. After selecting the group of material from this list, it is metal. Then say that it is made of steel. Okay, ordinary steel. Hold it and then drag the mouse toward the body and release the button. And then close this dialog box. Okay, to be able to see the model in the color of that metal, then select shaded option or realistic option, shaded or shaded with edges. Yes, it is made of steel. Or select shaded option. Yes. But since I selected now in the scenario, well, say that this object will be in contact with humidity air, humid air, wet air. So to be able to prevent corrosion, rusting, we need to paint the surfaces. In Inventor, remember, for instance, in this example, in the end, I painted all the surfaces in this color. With this, with the dye, it corresponds to this color. Its color is a tone of green. In the previous video record, I sufficiently talked about how surfaces are painted, how all the surfaces are painted. In AutoCAD, well, the painting tool, see where it is. Home ribbon, solid editing, and then here, well, extract edge, extrude faces. Well, not extrude face, but clicked on this listing arrow. Okay, it is a multi-optional facility. Well, the last option is on surface painting, color face, and then indicate the surface. Which surface? Make a click this surface. Which surface? Make a click this surface. Which surface? This surface. That surface. So on and so forth. Okay? Indicate the surface. Or just if you're going to paint only those surfaces, indicate them. But indicate them, okay. First study on such a case, press enter. And then, well, the color selection path will appear from true color or from index or color book. Select the color. For instance, I selected this color and then say OK. And then select exit option. Exit option. Well, do it again. I'm in doubt whether I made something by mistake. Color phase option I selected and then indicate the surface and then select the color, press enter, and then from the index select the color. For instance, I selected magenta and then say OK. Press enter, exit. Well, here there is a problem actually. Probably that command couldn't be converted to machine code. Why? Because in my computer, Windows Explorer probably stopped running. I'm going to try it again. Well, color phase option selected and then indicate the surface, this surface, this surface, okay, and then right click the mouse, press enter, selection stage, indicate, say finish the selection stage, and then clicked on a color option from here, or from there, which one is suitable. I selected the color and then say OK. And then select exit option. Enter a solid editing option. Say OK, exit. But it is not on the surface. So, well, there is a problem in my computer, but it is the procedure, my dear students. Well, I need to restart Windows Explorer to be able to achieve, to generate the machine code. Well, you know, in using software, high-level softwares, at the background, say while we are clicking on the process buttons, at the background, the corresponding click, such a click converted to is converted to a machine code, and then it is interpreted, and the output can be realized. But Windows Explorer, if Windows Explorer is running, it can be done. So probably Windows Explorer stopped running, that's why I vanish. But here it is the procedure. One more time, say select color phase option, and then if you're going to paint the surface, indicate surface. But if you're going to paint all the surfaces, click on down direction key and from the list select all option, and then press enter. And then select the color. For instance, color is blue, and then say OK. And then finish. But there is no paint. It will be painted if Windows Explorer were still in execution, in running. Okay, now I don't want to extend this video record too much, but say that, believe me, it is the procedure. Select the color phase option and indicate the surface, or select all option, clicking on down direction key and paint all the surfaces. Okay, finish this record. Dear students, well, finish this classwork. Bye bye.